May 22, 1943. The Naval Ammunition Depot at Hingham, Massachusetts. Lieutenant Norman Cahners stood in the cramped hold of a Liberty ship, watching a gang of stevedores struggle with wooden crates of 40mm ammunition. Sweat poured down their faces despite the cool New England morning. The men grunted and cursed as they maneuvered each crate into position, their movements slow, inefficient, dangerously haphazard. Cahners checked his stopwatch. 12 minutes to load just 8 crates. At this rate, filling this single cargo hold would take 3 days. The ship had 5 holds. Around him, similar scenes played out across dozens of vessels moored in Hingham Harbor. The United States Navy faced a logistical nightmare that threatened to strangle the entire Pacific campaign. American forces were advancing across thousands of miles of ocean, each island conquest demanding mountains of ammunition, food, and supplies. But the bottleneck wasn't production. American factories were churning out munitions at unprecedented rates. The problem was simpler and far more devastating. Nobody could figure out how to load and unload the damn ships fast enough. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Cahners, a 29-year-old Harvard graduate and former track athlete, had been assigned to the Naval Ordnance Materials Handling Laboratory 3 months earlier. His orders seemed straightforward: improve efficiency in cargo operations. The reality was far more daunting. The Navy was losing the war against the calendar. Every hour a ship sat at dock waiting to be loaded or unloaded was an hour it wasn't delivering critical supplies to forces fighting across the Pacific. The mathematics were brutal. A standard Liberty ship could carry 10,000 tons of cargo. Traditional break-bulk loading methods, using individual crates and boxes handled one at a time, required 14 days to fill a ship's holds. Another 14 days to unload at the destination. That meant each vessel spent 28 days in port for every round trip, sitting uselessly at the pier while cranes slowly moved cargo piece by piece. With German U-boats still prowling the Atlantic and Japanese submarines threatening Pacific supply lines, every ship was precious. The United States had embarked on the most ambitious shipbuilding program in history. Henry Kaiser's yards were completing Liberty ships in an average of 42 days. At peak production, they launched 3 ships every 2 days. But building ships meant nothing if those ships spent most of their time sitting in port. Cahners climbed out of the hold and stood on the deck, watching the chaos of the Hingham facility. The ammunition depot sprawled across hundreds of acres, its warehouses filled with every type of ordnance the Navy required: 40mm anti-aircraft rounds, 5-inch naval gun shells, depth charges, torpedoes, bombs ranging from 100-pounders to 1,000-pound monsters destined for B-17 and B-24 bombers. All of it needed to reach the Pacific. All of it was moving too slowly. The Navy had already made one crucial innovation. 2-way wooden pallets, combined with newly developed forklift trucks, were replacing the ancient practice of hand-carrying every box and crate. Workers could now stack cargo on these flat wooden platforms, and forklifts could lift and move entire pallet loads at once. The improvement was dramatic. A single forklift operator could move in 1 hour what previously required a dozen men working all day. Warehouse efficiency had doubled, sometimes tripled, but the pallets created a new problem that nobody had anticipated. Cahners walked to the edge of the pier and looked down at a forklift operator struggling to position a loaded pallet. The forklift's twin steel forks could only enter the pallet from 2 opposite sides. Inside a ship's hold, with limited maneuvering space and cargo already stacked floor to ceiling, this restriction was devastating. The operator had to approach each pallet from exactly the correct direction. If the pallet was oriented wrong, he had to back out, reposition his vehicle, try again. In the confined space of a cargo hold, this dance wasted precious minutes on every single load. Multiply those minutes by thousands of pallets, and you had ships sitting at dock for weeks. There had to be a better way. Cahners had grown up in Bangor, Maine, the son of a businessman who owned the local gas company and furniture business. From his father, he'd learned to see problems as opportunities. From his years at Phillips Academy and Harvard, where he'd excelled in track and field, He'd learned that success came from finding small advantages and exploiting them ruthlessly. He returned to his office in the materials handling laboratory, pulled out a sheet of paper, and began sketching. The problem was geometric. Current pallets, known as two-way entry pallets, had openings on only two sides. They consisted of a flat wooden top deck supported by long pieces of lumber called stringers that ran in one direction. Forklifts could slide their forks underneath these stringers from the front or back, but the solid sides blocked entry from left or right. What if, Cahners thought, the stringers were replaced with blocks? He drew a rectangle representing a pallet viewed from above. Instead of 3 long stringers running the length of the pallet, he sketched 9 wooden blocks arranged in a 3x3 pattern. These blocks would support the top deck just as effectively as stringers, but crucially, they would leave openings on all 4 sides. A forklift could approach from any direction, north, south, east, west. It wouldn't matter. The operator could slide the forks under the pallet and lift it without repositioning. The idea was so simple it seemed almost stupid. But Cahners had learned that the best solutions usually were simple. He brought his sketch to the depot's carpenter shop and explained what he needed. The carpenter, a grizzled veteran named Frank Morrison who'd been building wooden crates since the Great War, studied the drawing with skepticism. "That gonna hold a load?" Morrison asked. "Them blocks instead of full stringers?" "Only one way to find out," Cahners replied. They built the first prototype in an afternoon. 9 wooden blocks, each 6 inches by 6 inches, arranged to support a platform 4 feet wide by 4 feet long. The standard dimensions had emerged through trial and error over the previous 2 years as the military experimented with palletization. 48 inches by 48 inches fit efficiently into truck beds, rail cars, and ship holds. Cahners and Morrison loaded the prototype pallet with 8 crates of dummy cargo, roughly 800 pounds total. They called over a forklift operator. "Try picking it up from this side," Cahners instructed. The operator slid his forks under the pallet from the south side and lifted. The pallet rose smoothly, the load stable. "Now from this side." The operator set it down, repositioned 90 degrees, approached from the east. Again, the pallet lifted cleanly. They tested all 4 sides. Then they tested the corners. The operator discovered he could even approach at a 45-degree angle and still get his forks underneath. Morrison's skepticism melted into something approaching wonder. "I'll be damned," he muttered. "That actually works." Cahners felt the electric thrill of discovery. This simple modification, replacing 3 stringers with 9 blocks, had just eliminated the single biggest inefficiency in palletized cargo handling, but he needed to prove it at scale. Over the next 2 weeks, the carpenter shop built 30 test pallets. Cahners arranged a demonstration for Captain Robert Hendricks, the officer in charge of the ammunition depot. Hendricks was a career Navy man who'd spent 20 years managing supply operations. He'd seen 1,000 supposedly revolutionary ideas flame out in real-world conditions. "You're telling me these things load faster?" Hendricks asked, walking around one of the block pallets. 50% faster, sir. Maybe more." Hendricks raised an eyebrow. "Show me." They ran the test using 2 identical cargo holds on sister Liberty ships moored side by side. Both holds were empty. Both had identical loads of ammunition crates waiting on the pier, 40 pallets each. 20 experienced stevedores and forklift operators were divided into 2 teams of equal skill. One team would load using standard 2-way entry pallets. The other team would use Cahners' 4-way block design. Cahners stood on the pier with his stopwatch as Captain Hendricks gave the signal to begin. The difference was apparent within minutes. The team using 2-way pallets had to carefully position each load, backing up and repositioning when they approached from the wrong angle. Inside the hold, as stacks grew higher and maneuvering room decreased, the delays compounded. The team using 4-way pallets simply drove in, lifted, placed, and drove out. No hesitation, no repositioning. The forks slid under from any direction. When tight spaces developed in the hold, operators approached from whatever angle was most convenient. After 3 hours, both teams stopped for a break. Cahners tallied the results. The The two-way pallet team had loaded 22 pallets. The four-way pallet team had loaded 37. Hendricks did the math in his head. That's almost 70% faster. Yes, sir. If we could load every ship. 70% faster. Hendricks trailed off, his mind racing through the implications. Loading time that currently took 14 days could be cut to 8 days. Unloading likewise reduced from 14 days to 8. Instead of 28 days in port, ships would spend just 16 days. Multiply that across the entire fleet. Hundreds of Liberty ships, thousands of voyages, millions of tons of cargo. Son, Hendricks said quietly, I think you might have just won us a few months in this war. But the implications went far beyond simple time savings. The innovation would ripple through every aspect of naval logistics in ways nobody yet fully grasped. The Pacific War was fundamentally a war of distance and supply. American forces island-hopped across 6,000 miles of ocean from Hawaii to Japan. Each captured island needed to be transformed into a functioning base. Airfields had to be built, fuel depots established, ammunition stored, medical facilities erected, communications equipment installed, defensive positions constructed. All of it depended on cargo ships arriving with the necessary materials and supplies. In May of 1943, when Cahners developed his four-way pallet, the Marines had just secured Guadalcanal after 6 brutal months of fighting. The campaign had revealed stark truths about Pacific logistics. Japanese air and submarine attacks had sunk dozens of cargo ships. Those that survived faced devastating delays at primitive island ports with no cargo handling facilities. Ships anchored offshore and unloaded into smaller boats that ferried supplies to the beach. The process was agonizingly slow. A ship that could be emptied in 2 weeks at a modern port might take 6 weeks at an island anchorage. The four-way pallet couldn't solve all these problems, but it could make every stage of the process faster. From warehouse to ship, from ship to barge, from barge to beach, from beach to forward supply dump. Speed meant ships spent less time in dangerous waters. Speed meant supplies reached combat units faster. Speed meant fewer bottlenecks choking the entire supply chain from California to Saipan. Cahners filed his patent application in May of 1943. The patent would eventually be numbered 2,053,999. But he didn't wait for patent approval to begin production. The Hingham Depot's carpenter shop ramped up immediately. They weren't just building pallets anymore. They were building a system. Cahners realized that the four-way pallet's full potential could only be realized if cargo was packed to fit the pallets efficiently. He began designing what he called unit loads, standardized configurations of boxes and crates that stacked perfectly on a 40-inch by 48-inch platform. Working with ordnance specialists, he developed loading patterns for different types of ammunition. 40mm shells came in specific wooden crates. How many crates could stack on one pallet while maintaining stability and staying under the weight limit? He calculated the answer. 16 crates arranged in a 4x4 pattern, each layer separated by wooden dunnage to prevent shifting. For 5-inch naval shells, the number was different. The crates were larger, heavier. Only 6 could fit per pallet, arranged 3x2. Smaller caliber ammunition could be packed more densely. Larger items like depth charges required their own loading configurations. Cahners documented everything. He created diagrams showing the optimal arrangement for each ammunition type. He specified how many layers could be stacked safely. He calculated weight distributions to prevent pallets from becoming top-heavy and unstable. This work was tedious, unglamorous, and absolutely critical. The best pallet design in the world was useless if cargo handlers loaded it incorrectly. To spread this knowledge, Cahners started a newsletter. He called it The Palletizer. The publication was technically produced by the Naval Ordnance Materials Handling Laboratory, but Cahners wrote most of the content himself. Each issue featured practical advice on pallet loading, forklift operation, warehouse organization, and cargo security. The Navy distributed the palletizer to contractors, shipyards, and ammunition depots across the country. Civilian companies building munitions learned how to pack their products for maximum efficiency. Port operators learned how to organize cargo for faster loading. Ships' officers learned how to plan their holds to optimize both space and unloading sequence. The newsletter became the handbook for an emerging industry. Material handling, as a distinct professional discipline, was being invented in real time to meet the demands of global war. By August of 1943, the four-way pallet had spread beyond the Hingham Depot. Other naval facilities began adopting it. The Army's Quartermaster Corps took notice and started developing their own block pallets. The real test came when the Navy decided to try palletized cargo in combat conditions for the first time. The 1st Marine Division was preparing for its next major offensive. After the nightmare of Guadalcanal, the Marines were landing at Cape Gloucester, on the island of New Britain, in December of 1943. The operation would require massive amounts of ammunition, food, and supplies delivered across thousands of miles of ocean to a primitive beach with no port facilities. The Navy selected this operation as a trial for full-scale palletization. Ships leaving California ports would load ammunition on four-way pallets. Those pallets would remain intact throughout the journey. When the ships reached Cape Gloucester, the pallets would be lifted from the holds, loaded onto barges, ferried to the beach, and transported inland. No repackaging, no repacking, no individual handling of thousands of small boxes and crates. Cahners travelled to San Francisco to supervise the loading. He'd never seen an operation at this scale. Dozens of Liberty ships lined the piers. Warehouses stretched for miles, packed with munitions. Forklifts swarmed like mechanical ants, each one moving a pallet load worth nearly a 7-ton. The loading crews had been trained in the new methods. They'd read the palletizer. They knew the unit loading patterns. But theory and practice were different things. Problems emerged immediately. Some pallets arrived at the pier loaded incorrectly. The cargo shifted during transport, making the loads unstable. When forklifts tried to lift them, boxes tumbled off. Other pallets exceeded the weight limits. A forklift rated for 2,000 pounds struggled when operators overloaded pallets to 3,000 pounds or more. The hydraulics groaned. The forks bent. Some dock workers, accustomed to the old two-way pallets, approached from only two sides out of habit, negating the four-way design's advantages. Cahners spent 18-hour days troubleshooting. He adjusted loading patterns. He retrained operators. He identified weak points in the system and developed solutions. Gradually, the operation found its rhythm. Ships that previously took 2 weeks to load were being filled in 9 days. The improvement wasn't as dramatic as the initial 70% gain from the controlled tests, but in real-world conditions with imperfect execution, a 35% improvement was extraordinary. The convoy departed San Francisco in early December. Cahners watched the last ship disappear over the horizon and felt a mixture of pride and anxiety. His innovation was heading into combat. Lives would depend on how well it worked. The report came back 6 weeks later. Marine Lieutenant General Charles F.B. Price had overseen the unloading operations at Cape Gloucester. His assessment, transmitted through official Navy channels, reached Cahners at Hingham. The palletized cargo arrived in excellent condition with practically no breakage and no pilferage, either en route or during unloading here and distribution ashore. Handling operations were accomplished at a far more rapid rate than anticipated. Request future shipments utilize similar methods. Cahners allowed himself a rare moment of satisfaction. It had worked. Under combat conditions, with inexperienced handlers, on primitive beaches under threat of Japanese air attack, the system had performed better than anticipated. The Navy wasted no time scaling up. By March of 1944, palletized loading had become standard procedure for Pacific-bound cargo. Ammunition depots from Norfolk to Seattle began mass-producing four-way pallets. Forklift production, already ramping up to meet industrial demands, accelerated further. The numbers were staggering. In 1941, approximately 25,000 forklifts operated in the entire United States. By 1945, that number exceeded 60,000, with half allocated to military operations. Pallet production grew even more dramatically. In 1942, American military depots produced approximately 6 million pallets of all types. By 1944, that figure reached 30 million pallets annually. By war's end, over 100 million pallets had been manufactured for the military effort. The standardization Cahners had pushed for early in the process paid enormous dividends. The 40-inch by 48-inch pallet became the de facto military standard. Trucks, rail cars, warehouse racks, ship holds, all were designed around this dimension. A pallet loaded in Kansas City would fit perfectly in a warehouse in Manila. This interoperability was revolutionary. For the first time in military history, cargo could move from factory to front line without being repacked. The pallet became the fundamental unit of military logistics, like the shipping container would become for civilian commerce 20 years later. The efficiency gains cascaded through the system in ways that were hard to quantify, but impossible to ignore. Ships spent less time in port, which meant each ship could make more voyages per year. This was equivalent to having more ships, except without the enormous cost and time of actually building them. A Liberty ship that previously made 4 round trips per year could now complete 6 trips. That 50% increase in efficiency was like adding hundreds of vessels to the fleet without laying a single keel. Warehouses processed more cargo with fewer workers. Before palletization, a typical quartermaster depot employed 500 men to handle its daily volume. With forklifts and pallets, the same facility could process double the volume with 300 men. Those 200 workers were freed for other duties. Many went into the military itself, becoming soldiers and sailors rather than warehouse laborers. This labor reduction was especially important because it allowed women to fill material handling roles. Operating a forklift required skill and training, but not the physical strength needed to manhandle 100-pound crates. Women worked alongside men in depot operations, helping to maintain the flow of supplies, while able-bodied men went to the front. Cargo security improved dramatically. Pallet loads were wrapped and sealed as complete units. Pilferage, which had plagued military supply operations since the Roman legions, dropped to negligible levels. When a load arrived with a broken seal, investigators knew exactly where the theft had occurred. Cargo damage decreased for similar reasons. Individual boxes tended to shift during transport, getting crushed or broken. Palletized loads, properly secured, traveled as solid units. Ammunition that might have been jolted and damaged by rough handling now arrived in perfect condition. The speed improvements had second-order effects that were harder to measure, but perhaps more important than the direct time savings. Faster delivery meant fresher food reaching troops. It meant medical supplies arriving before they expired. It meant ammunition resupply happening quickly enough to support sustained offensive operations. Commanders could be more aggressive because they knew supplies would arrive on schedule. The nightmare scenario, where an offensive stalled because ammunition ran out, became far less likely. By summer of 1944, as the United States prepared for the largest amphibious operations in the Pacific Theater, the infrastructure Cahners had helped build was operating at full capacity. The Marianas Campaign, targeting the islands of Saipan, Tinian, and Guam, would require landing over 70,000 troops. Supporting those troops meant delivering tens of thousands of tons of ammunition, food, fuel, medical supplies, and construction materials. Every ounce of it would arrive on pallets, handled by forklifts, loaded and unloaded in a fraction of the time that would have been required 2 years earlier. But perhaps most remarkably, the innovation that began with Cahners' simple sketch was now spreading beyond the military. Civilian industry had watched the military's success with palletization. Defense contractors, already using pallets to ship goods to the military, began seeing applications in their peacetime operations. Why move boxes individually when you could move them in pallet loads? Trucking companies, railroads, and warehouse operators began experimenting with palletized freight. The efficiencies that benefited the military would work equally well for commercial cargo. Cahners, still a Navy lieutenant working at the Hingham Depot, had begun to think about what might happen after the war. He'd revolutionized military logistics. Could the same principles transform civilian commerce? He envisioned a world where pallets and forklifts were as common as trucks and handcarts, where every warehouse, Every factory, every loading dock was designed around palletized handling, where cargo flowed smoothly from producer to consumer with minimal human labor. It seemed almost utopian. But then again, 2 years earlier, the idea of loading a ship in 9 days instead of 14 had seemed impossible. The war was teaching lessons that would reshape the peacetime economy. Mass production, standardization, system optimization. These were military necessities that would become peacetime advantages. As 1944 turned into 1945 and American forces drove relentlessly toward Japan, the logistics system that Cahners had helped build operated with clockwork precision. Ammunition flowed from American factories to Pacific islands in an unbroken stream. The tonnage was almost incomprehensible. During the Okinawa campaign in April of 1945, American forces expended over 60,000 tons of ammunition in the first month alone. All of it had been shipped across 6,000 miles of ocean, loaded and unloaded multiple times, and delivered to the exact spot where it was needed, exactly when commanders needed it. The system that made this possible had been built on thousands of small innovations, but the four-way pallet was fundamental. Without it, the ships would still be sitting at the docks. The invasions would have been delayed. The war would have dragged on for months or years longer. Norman Cahners never claimed he won the war, but he'd removed one of the critical bottlenecks that could have lost it. The official recognition came in 1944. The Navy commended Cahners for his innovation, stating in formal language that his design had saved the United States taxpayers millions of dollars and thousands of man-hours. The commendation was filed in his service record and essentially forgotten amid the vastly larger events of the Pacific War. But the impact of his work was anything but forgotten by those who depended on it. Ship captains whose vessels could now turn around in days instead of weeks, stevedores who could load in hours what previously took days, supply officers who could actually keep pace with combat consumption, Marines and soldiers who never had to face the nightmare of running out of ammunition because ships couldn't be unloaded fast enough. To them, the four-way pallet was as important as any weapon in the American arsenal. The scale of the transformation became clear when analyzed statistically. Before palletization, the average tons handled per man at quartermaster corps depots was approximately 14 tons per day in the third quarter of 1943. By the second quarter of 1945, that figure had risen to 28 tons per man per day. Productivity had doubled. Rail freight cars, desperately needed to keep supplies moving across the United States, spent far less time sitting at loading docks. A boxcar that previously waited 2 days to be unloaded was now emptied in 6 hours. This multiplied the effective capacity of the American rail system without laying a single additional mile of track. Cargo ships, the lifeblood of the Pacific campaign, achieved similarly dramatic improvements. The average time a Liberty ship spent in port dropped from 28 days to 16 days. For the roughly 2,700 Liberty ships built during the war, this represented millions of ship days of additional capacity. It was as if the United States had built an extra 1,000 ships without the expense and time of actually constructing them. The labor savings were equally significant. In 1942, moving 100 tons of cargo through a typical depot required 40 man-hours of work. By 1945, the same 100 tons required only 12 man-hours. This threefold improvement in labor efficiency freed hundreds of thousands of workers for other tasks, either in war production or military service. Even more remarkable was what didn't happen: injuries from material handling, which had plagued military operations since ancient times, dropped precipitously. A stevedore lifting 100-pound crates all day inevitably suffered back injuries, hernias, and chronic pain. A forklift operator sat in a relatively comfortable seat and used mechanical power to move the same weight. Accident rates fell, medical costs decreased, morale improved. But perhaps the most important impact was psychological rather than statistical. The four-way pallet, combined with the broader palletization system, gave American forces an unshakable confidence in their logistics. They knew supplies would arrive. They knew ammunition would be available. They knew the system wouldn't fail. This confidence enabled aggressive tactics that exploited American material superiority. Commanders could launch offensives knowing they could sustain high rates of ammunition expenditure. Artillery officers could order heavy bombardments without worrying about running out of shells. Infantry could fight with the assurance that resupply was guaranteed. The contrast with Japan was stark and decisive. Japanese forces, cut off from their supply lines by American submarines and aircraft, had to husband every round, every mortar shell, every rifle, cartridge. American forces could expend ammunition with a profligacy that would have been unthinkable in any previous war. This disparity didn't just affect combat outcomes, it affected how soldiers and Marines approached battle. Japanese troops, knowing they might run out of ammunition, often launched desperate banzai charges in suicidal attempts to overwhelm American positions before their supplies ran out. American troops, confident in unlimited resupply, could fight methodically, using overwhelming firepower to reduce Japanese strongpoints with minimal American casualties. The four-way pallet hadn't created American industrial superiority, but it had ensured that industrial superiority translated into battlefield advantage. There's no point in producing millions of tons of ammunition if you can't deliver it where it's needed, when it's needed. As the war drew to a close in August of 1945, following the atomic bombings of Hiroshima and Nagasaki, the logistics system that Cahners had helped build faced one final massive challenge. The United States military had been preparing for Operation Downfall, the planned invasion of Japan. The operation would have been the largest amphibious assault in history, dwarfing even D-Day. Supplying the invasion force would have required moving millions of tons of material across the Pacific. Every calculation, every plan, every logistics schedule had assumed palletized cargo handling. Without it, the operation would have been delayed by months, while supply stockpiles slowly accumulated. The atomic bombs made the invasion unnecessary, but the plans revealed just how dependent American strategy had become on the innovations of the past 4 years. Palletization wasn't a nice-to-have efficiency improvement, it was essential infrastructure without which the Pacific War couldn't have been fought. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. When the war ended, Norman Cahners faced a decision that would shape the rest of his life. He was 31 years old, a Navy lieutenant with a patent on one of the most important logistics innovations of the 20th century. What came next? The Navy offered him the option to continue the Palletizer as a private publication. The government had no interest in running a newsletter about material handling after the war ended, but Cahners could take it over if he wanted. He wanted to. In November of 1946, he changed the publication's name to Modern Materials Handling. The first civilian issue featured the same practical, detailed advice that had characterized the wartime edition: how to design efficient warehouse layouts, how to select the right forklift for specific applications, how to calculate return on investment for palletization systems. The audience wasn't military contractors anymore. It was civilian businesses trying to adapt wartime, innovations to peacetime commerce. Grocery chains, department stores, manufacturing facilities, trucking companies. They'd all seen what palletization could do for military logistics. Now they wanted those same efficiencies in their operations. Cahners had found his calling. He sold his pallet patents and licenses, closed the materials handling laboratories he'd established during the war, and devoted himself full-time to publishing. Modern Materials Handling became the flagship of what would eventually become Cahners Publishing Company. The business grew rapidly. Cahners understood something fundamental about the post-war American economy. It was becoming more complex, more specialized, more dependent on efficient logistics. Every industry had unique challenges and needed specialized information. He began acquiring other trade magazines, launching new publications, targeting specific business audiences. By the time of his death in 1986, 3 weeks before his planned retirement, Cahners Publishing had grown to 90 magazine titles. It had become the largest publisher of trade and business magazines in the United States. The company would eventually be acquired by Reed Elsevier and rebranded as Reed Business Information, but the Cahners name lived on in industry memory. Norman Cahners had become a publishing magnate, a philanthropist whose name adorned concert halls and university buildings. But his most important contribution remained that simple sketch he'd drawn in May of 1943, showing 9 blocks arranged to support a wooden platform. The 4-way pallet spread far beyond military applications. By the 1950s, American businesses were using millions of pallets annually. By the 1960s, palletization had become standard practice in virtually every industry that moved physical goods. By the 1970s, the global economy was built on a foundation of palletized cargo. Today, approximately 2 billion pallets circulate through the United States economy alone. Over 500 million new pallets are manufactured each year globally. Roughly 90% of all goods move on pallets at some point in their journey from factory to consumer. The 4-way design that Cahners pioneered became the industry standard. Modern pallets can be accessed from any direction, lifted from any angle, stacked efficiently in any configuration. They're the invisible infrastructure of global commerce, so ubiquitous that people rarely notice them despite handling billions of dollars worth of goods daily. But the military never forgot where palletization came from or what it had accomplished. The lessons learned in World War II shaped military logistics for every subsequent conflict. Korea, Vietnam, the Gulf Wars, Afghanistan, Iraq, all of these campaigns depended fundamentally on efficient cargo handling systems that traced their lineage directly back to Cahners' innovation. During the Vietnam War, American forces moved more cargo through Vietnamese ports than had flowed through all Allied ports combined during World War II. They did it with a fraction of the labor, in a fraction of the time. Palletization made it possible. When the United States launched Operation Desert Storm in 1991, moving over 500,000 troops and millions of tons of equipment to Saudi Arabia in a few months, the entire operation depended on containerized and palletized shipping. The speed of the build-up shocked Iraqi commanders, who had assumed the Americans would need a year to assemble such a force. Even today, as the American military focuses on great power competition and the possibility of conflict in the Pacific, logistics planners study the lessons of World War II. How do you move vast quantities of material across oceanic distances? How do you maintain supply lines stretching thousands of miles? How do you ensure combat forces never run out of ammunition? The answers all trace back to innovations developed under pressure between 1941 and 1945. Innovations like the 4-way pallet, but the story has a deeper significance beyond military history or logistics efficiency. It's about how wars accelerate innovation, how necessity forces creative thinking, how simple solutions to complex problems sometimes emerge from unexpected places. Norman Cahners wasn't a professional logistics expert when he joined the Navy. He was a Harvard graduate with a background in track and field who'd never thought seriously about cargo handling before the war. But when faced with a problem that threatened to undermine the entire Pacific campaign, he approached it with fresh eyes, unconstrained by assumptions about how things had always been done. The Navy's willingness to experiment was equally crucial. In the middle of history's largest war, senior officers took time to test a new pallet design. They ran controlled experiments. They measured results. They scaled up what worked. This culture of innovation, of trying new approaches and discarding what failed, characterized American industrial mobilization throughout the war. The contrast with Germany and Japan was striking. Both nations had skilled engineers and innovative thinkers. Both developed impressive weapons and technologies, but neither created the systematic approach to logistics optimization that characterized American operations. German forces in World War II never solved their logistics problems. They relied heavily on horses for transport even late in the war, while American forces mechanized virtually everything. German supply lines constantly struggled to keep pace with armored advances. Panzer divisions that should have been unstoppable were often immobilized, waiting for fuel and ammunition. Japanese logistics were even worse. The Imperial Japanese Army and Navy competed for limited resources rather than cooperating. Supply lines across the Pacific were decimated by American submarines. Japanese forces on isolated islands sometimes starved while waiting for supply ships that never arrived. American logistics weren't perfect. There were failures and bottlenecks. The supply crisis in Europe during the autumn of 1944, when advancing armies outran their supply lines, demonstrated that even the best systems could be overwhelmed. But when problems emerged, American forces adapted quickly. They innovated solutions. They implemented changes. This adaptability was itself a form of technological advantage. The four-way pallet wasn't high technology. It was wood and nails. But it solved a real problem efficiently, and it was deployed at scale rapidly. That combination of practical innovation and rapid implementation characterized American success throughout the war. The story also reveals how interconnected military systems are. The four-way pallet seems like a minor detail, barely worth mentioning alongside aircraft carriers and atomic bombs. But logistics is the foundation on which everything else rests. The most powerful weapons are useless if they can't be delivered to the battlefield. The best trained troops can't fight without ammunition and food. Understanding this interconnectedness was one of America's greatest advantages. Industrial production, transportation, infrastructure, cargo handling efficiency, all worked together as an integrated system. Improvements in one area multiplied the effectiveness of all the others. Henry Kaiser's Liberty ships needed cargo to carry. The cargo needed pallets for efficient handling. The pallets needed forklifts to move them. The forklifts needed trained operators. The operators needed standardized procedures. The procedures needed documentation like the palletizer. Every piece depended on every other piece. This systems thinking, this recognition that war was won by integrated industrial military capabilities rather than individual weapons, was perhaps America's most important innovation. It wasn't glamorous. It didn't make exciting newsreels. But it won the war as surely as any battle or bombing campaign. The human cost of efficient logistics is harder to quantify, but no less real. Every ship that reached port faster meant fewer days in danger from submarines or air attack. Every ton of ammunition delivered on schedule meant operations could proceed as planned, rather than stalling under enemy counterattack. Every reduction in loading time meant sailors and stevedores spent fewer hours in exhausting, dangerous manual labor. Lives were saved by pallets, not in dramatic, visible ways like a medic treating wounded soldiers, but in aggregate, across thousands of operations over 4 years of global war. Sailors who didn't die when their ship was sunk because it had already finished unloading and departed. Marines who didn't run out of ammunition at a critical moment because resupply arrived on schedule. Workers who didn't suffer crippling injuries because forklifts replaced manual lifting. These invisible victories don't make for exciting stories. Nobody receives medals for efficient cargo handling, but they mattered just as much as heroism in combat. Norman Cahners understood this in a way that many people didn't. In interviews later in life, he rarely discussed his wartime service. When pressed, he would describe the problem he'd been trying to solve and the solution he'd developed, but always in modest terms. He didn't claim to have changed the course of the war. He'd simply made cargo handling a bit more efficient. But those who understood logistics knew better. Admiral Samuel Eliot Morrison, the official historian of U.S. naval operations in World War II, wrote extensively about logistics in the Pacific. He noted that American success wasn't primarily due to superior tactics or braver soldiers. It was due to overwhelming material superiority, delivered where it was needed, when it was needed. That delivery system depended on innovations like the four-way pallet. The numbers tell the story. From December of 1941 through August of 1945, the United States shipped approximately 68 million measurement tons of cargo to overseas theaters. Roughly 42 million tons went to the Pacific. The rest went to Europe, North Africa, and other theaters. During the peak months of 1944 and 1945, American ports were loading over 3 million tons of cargo monthly. Ships were arriving, loading, and departing with mechanical regularity. The system that Norman Cahners had helped build was operating at full capacity, sustaining the largest military operations in human history. Without palletization, This volume would have been impossible. The ports would have been hopelessly clogged, ships would have queued for weeks waiting to load. The entire offensive momentum would have stalled. Germany and Japan counted on this happening. They believed American logistics would collapse under the weight of global war. They assumed distance and complexity would defeat the United States before their military forces did. They were catastrophically wrong. American logistics didn't just function. They excelled. They delivered more material, more reliably, across greater distances than any supply system in history. The four-way pallet was one small piece of that achievement, but like a keystone in an arch, its importance exceeded its size. Remove it, and the entire structure would have been significantly weaker. This is the fundamental lesson of the story. Wars aren't won by single decisive weapons or brilliant generals alone. They're won by systems, logistics systems, production systems, training systems, information systems. All working together, each piece optimized, all pieces integrated. The Manhattan Project produced atomic bombs, but those bombs had to be delivered by modified B-29s that had been manufactured in factories supplied by railroads that ran on time because cargo handling was efficient. The Normandy invasion succeeded because of meticulous planning, but that planning assumed ships could be loaded on schedule, which required palletized cargo handling that had been perfected in the Pacific. Everything connected to everything else. Cahners' simple innovation with 9 wooden blocks rippled outward through the entire war effort. By the time Japan surrendered in August of 1945, the United States military had become a finely tuned logistics machine. Supplies flowed from American factories to battlefields on the other side of the world with assembly line precision. The system could deliver specific items to specific units at specific times with extraordinary reliability. This capability, more than any weapon or tactic, demonstrated American military superiority. The Axis powers could match American courage. They could sometimes match American tactical skill. They had no answer to American logistics. When the war ended and troops began the long journey home, that same logistics system operated in reverse. Millions of soldiers needed to be demobilized and transported back to the United States. Equipment needed to be recovered or disposed of. Supplies needed to be accounted for and redistributed or sold as surplus. The operation was enormous and complex. It succeeded largely because the infrastructure was already in place. The ships, the ports, the cargo handling equipment, the trained personnel, all existed and functioned efficiently. Pallets loaded with soldiers' duffel bags and personal equipment moved through the system just as efficiently as pallets of ammunition had moved during the war. The same forklifts that had loaded 5-inch shells now loaded footlockers and sea bags. The same efficient procedures that had characterized wartime operations carried over into peacetime demobilization. By 1946, most American troops were home. The military had shrunk, from 12 million personnel to fewer than 3 million. The vast infrastructure of war was being dismantled or converted to peacetime use. The pallets remained. Businesses bought war surplus forklifts and pallets. They discovered that the efficiency gains that had helped win the war worked equally well in civilian commerce. Warehouses redesigned around palletization could handle more goods with fewer workers. Trucking companies could load and unload faster. Railroads could turn around freight cars more quickly. The American post-war economic boom of the 1950s and 60s was built on many foundations: interstate highways, suburban development, mass consumption. But underneath all of it was an increasingly efficient logistics system that could move goods from manufacturer to consumer faster and cheaper than ever before. Palletization was central to that system. The humble wooden pallet, invented out of wartime necessity, became peacetime infrastructure. Norman Cahners, watching from his publishing offices in Boston, saw his innovation transform the civilian economy just as it had transformed military logistics. Modern materials handling chronicled the changes. Each issue featured case studies of businesses implementing palletized handling. Each article documented productivity gains and cost savings. Cahners had become wealthy from publishing, not from pallets. He'd sold his patents years earlier for modest sums. If he'd maintained control of the four-way pallet patent and charged royalties, he might have become one of the richest men in America. Billions of pallets have been built using his design, but he never expressed regret. The satisfaction came from solving a problem, from contributing to victory, from seeing an idea take root and flourish. The money from publishing was more than enough. He did, however, take pride in what the innovation had achieved. When historians later interviewed him about his wartime service, he emphasized not his personal contribution but the broader principle. Americans won World War II because they were willing to rethink everything. Nothing was sacred. Any process could be improved. Any problem could be solved if you approached it creatively. The four-way pallet embodied that spirit. It wasn't revolutionary technology. It was a simple modification to an existing design, but it came from questioning assumptions. Why should pallets only have two-way entry? Because that's how they'd always been built. But was that the best design? No. So change it. This willingness to challenge convention, to experiment, to adopt better methods even if they disrupted established practices, characterized American innovation throughout the war. It created superior weapons, better tactics, more efficient production, and ultimately, victory. The war had forced America to innovate at unprecedented speed and scale. Peacetime would reveal whether those lessons could be sustained. For Norman Cahners, the answer was yes. His publishing empire was built on the same principle that had created the four-way pallet. Identify a problem, develop a solution, implement it, measure results, improve continuously. Modern materials handling wasn't just reporting on logistics innovation, it was driving it. Each issue introduced readers to new equipment, new methods, new ways of thinking about cargo handling. The magazine became the hub of an emerging professional community of materials, handling engineers, warehouse managers, and logistics specialists. These professionals, many of them veterans who'd learned palletized handling in the military, spread the gospel of efficiency through American industry. They designed warehouses, they specified equipment, they trained operators, they optimized systems. Within 20 years, the transformation was complete. American commerce ran on pallets. Foreign companies, watching American productivity gains, adopted the same methods. By the 1970s, palletization had become global standard practice. The wooden pallet, that simple platform of boards and blocks, had become one of the most important objects in the world economy. More goods traveled on pallets than on any other platform. More economic value rested on wooden platforms than in many nations' treasuries. And it all traced back to a Navy lieutenant standing in a ship's hold in May of 1943, watching stevedores struggle with two-way pallets and thinking, there has to be a better way. That moment of recognition, that spark of insight, had consequences far beyond anything Cahners could have imagined. The four-way pallet helped win history's largest war. It transformed global logistics. It enabled the post-war economic boom. It created an entire industry around materials handling. Not bad for 9 blocks of wood and a simple idea. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.